There is a world out there, almost 1 billion miles from where you rest tonight, that is slowly losing its crown. Saturn, the jewel of our solar system, is watching its magnificent rings vanish before our eyes. Not in some distant, theoretical future, but right now, as you breathe, as you settle into the comfort of your pillow. The rings are raining down upon the planet itself, a quiet dissolution happening at a pace that fills an Olympic swimming pool every 30 minutes with particles of ancient ice. And if that were not strange enough, twice a year the rings perform another vanishing act, an optical illusion so perfect that even through our most powerful telescopes, they simply disappear. Welcome to Nap Labs, where we explore the universe slowly, gently, letting wonder wash over us like a warm tide. Tonight, we journey to Saturn to understand both its temporary illusions and its permanent mysteries. As you listen, let your mind drift outward, past the Moon, past Mars, beyond the asteroid belt, to where this giant world spins in the cold darkness, crowned in light, but losing that crown grain by grain, moment by moment. If you feel moved, drop a comment below with where you are listening from tonight, your local time, your corner of Earth. It helps us know how far these words travel, and it connects us all under the same vast sky. Let us begin with the mystery that has captivated astronomers in recent months. Saturn's rings vanished from view on March 23rd, 2025, a phenomenon that occurs roughly every 13 to 15 years. The rings do not truly disappear. They remain exactly where they have always been, orbiting Saturn's equator in an elegant, impossible thinness. But from Earth, from our particular angle in space at that moment, they become invisible. It is like holding a sheet of paper horizontally at eye level and then tilting it slowly until only its edge faces you. The paper has not vanished, but your perspective has changed so dramatically that it seems to have ceased to exist. Saturn's rings, despite spanning 282,000 kilometers across, measure only around 1 kilometer in thickness. When Earth crosses through Saturn's ring plane, when we align perfectly with that razor-thin edge, the rings reflect almost no light back to us. They fade from view as if they were never there at all. This is not the first time humans have witnessed this celestial magic trick. Galileo Galilei, testing his primitive telescope in 1610, saw what he called Saturn's ears, strange protrusions on either side of the planet that baffled him completely. In 1612, those ears mysteriously vanished, leaving Galileo confused and perhaps a bit shaken. He had no way of understanding that he was witnessing a ring plane crossing, that the geometry of planetary orbits was playing tricks on his perception. Today, we know exactly what Galileo could not. We understand the elegant mechanics behind the disappearance, but understanding does not diminish the wonder. If anything, it deepens it. Saturn takes 29.4 Earth years to complete one orbit around the Sun, and its axis is tilted by 26.7 degrees. This tilt gives Saturn seasons, just as Earth has seasons, though each Saturnian season lasts more than 7 Earth years. As Saturn travels its long journey around the Sun, and as Earth speeds along its own much faster orbit, our viewing angle of Saturn's rings constantly shifts. Sometimes we gaze down upon the rings from above, seeing their full breadth illuminated by sunlight. Sometimes we peer up at them from below, and twice during Saturn's orbital period, we find ourselves looking directly at their edge. During these moments, the rings perform their vanishing act. They did so in March, and then once more in November of 2025, before gradually returning to full visibility by 2032. But here is where the story takes a darker turn, a gentle melancholy that adds weight to our wonder. The rings are not just disappearing temporarily, they are disappearing permanently, slowly, inexorably. Scientists estimate that Saturn's ring system will be gone in less than 100 million years, possibly as few as 15 million. Every 30 minutes, enough water from the rings to fill an Olympic-sized swimming pool rains down onto Saturn. This process, discovered through observations from the Voyager spacecraft in the 1980s and confirmed by the Cassini mission, is called ring rain. It is both beautiful and heartbreaking, a slow dissolution of something magnificent. Ring rain happens because Saturn's powerful magnetic field pulls electrically charged ice particles from the rings down into the planet's upper atmosphere. Ultraviolet light from the sun charges these tiny grains of ice, giving the magnetic field something to grip. The particles spiral down invisible field lines, disappearing into Saturn's clouds like snowflakes falling into an ocean. Jack Connerly of NASA Goddard first proposed this mechanism in 1986, linking strange dark bands in Saturn's atmosphere to the magnetic field shape and the influx of ring material. What began as a curious observation has become a countdown to extinction. The rings we see today, the rings that have symbolized Saturn for as long as humans have gazed at the night sky through lenses, are temporary. They are young, cosmically speaking, probably less than 100 million years old. Saturn itself is 4.5 billion years old, ancient and weathered by time. Its rings are infants by comparison, a recent adornment, a crown acquired late in life and destined to be lost before the planet's story ends. This knowledge adds a bittersweet quality to every image of Saturn. We are witnessing something ephemeral. In the deep future, when our sun is still burning and Saturn still orbits, the planet will be bare. Future civilizations, if any exist, will know Saturn only as a ringless giant, a gas planet like Jupiter or Neptune. Interesting perhaps, but not iconic. They will look at our photographs and feel what we feel when we see reconstructions of extinct animals, a sense of loss for something beautiful that once was. But that future is not yet. Tonight, the rings are still there, still brilliant, still spinning in their ancient dance. And tonight, you can imagine them, even as you rest, even as you drift towards sleep. To truly understand Saturn, we must first grasp its size, its immensity. Saturn is enormous. It has a radius about 9 times that of Earth. If Earth were the size of a grape, Saturn would be a basketball. But despite being 95 times more massive than our world, Saturn is remarkably light. Saturn would float if placed in a sufficiently large body of water, an amusing thought experiment that speaks to the planet's composition. Saturn is mostly hydrogen and helium, the simplest and lightest elements in the universe, compressed by gravity into a vast sphere but never dense enough to sink. It is a balloon of cosmic gas, held together by its own weight, spinning rapidly through the void. A day on Saturn lasts just 10.5 hours. The planet rotates faster than any other planet except Jupiter, completing a full spin in less than half an Earth day. This rapid rotation creates powerful forces that shape everything about Saturn, from its slightly flattened appearance at the poles to the howling winds that rage through its atmosphere. At the equator, winds reach speeds of over 1,400 kilometers per hour, faster than any terrestrial tornado, faster than sound itself in Earth's atmosphere. These winds are not driven by solar heating, as winds on Earth are. Saturn receives only about 1% of the sunlight that Earth receives, a wan, distant glow that provides little energy for weather. Instead, Saturn's winds are powered from within, by heat rising from the planet's interior, by the residual warmth of its formation 4.5 billion years ago. The planet is still cooling, still radiating more energy than it absorbs from the sun, and that internal heat drives a weather system of staggering complexity and violence. Saturn sits far from the sun, an average distance of 1.43 billion kilometers, or about 9.5 astronomical units. An astronomical unit is the distance from Earth to the Sun, our baseline for measuring the solar system. Saturn is 9.5 times farther from the Sun than we are. Light from the Sun takes 80 minutes to reach Saturn. If you stood on one of Saturn's moons and watched the Sun, you would see it as a bright star, noticeably larger than the other stars, but not the overwhelming disk that dominates our earthly sky. Daylight on Saturn is a twilight by our standards, a permanent dusk that never brightens into noon. The planet's atmosphere is a churning sea of hydrogen and helium, with traces of methane, ammonia, water vapor, and other compounds. The colors we see in Saturn's clouds come from these trace elements. Ammonia ice crystals create pale yellows and whites. Sulfur and phosphorus compounds, produced by lightning and other chemical processes, add reds and browns. The colors are subtle, muted compared to Jupiter's vivid bands, but they are there, swirling in patterns that shift over days and weeks. Saturn's atmosphere is layered, with different temperatures and pressures at different altitudes. Near the top, where sunlight can reach, the temperature drops to minus 180 degrees Celsius, cold enough to freeze carbon dioxide solid. Deeper down, the atmosphere grows warmer and denser. At some depth, there is no clear boundary between atmosphere and interior. The gas simply becomes thicker and thicker, transitioning gradually from a gas to a liquid to a metallic form of hydrogen, all without ever encountering a solid surface. Saturn has no ground to stand on, no ocean floor to touch. It is atmosphere all the way down until the pressure becomes so immense that hydrogen itself transforms into something strange and unfamiliar. At the very center of Saturn, buried beneath tens of thousands of kilometers of compressed gas, there may be a core of rock and ice, a solid seed around which the rest of the planet accumulated. Or there may not be. The core, if it exists, is hidden from us, impossible to observe directly. Cassini's measurements during its final plunge into Saturn's atmosphere provided some clues about the interior structure, but the deepest regions remain mysterious. We can model them, simulate them, estimate their properties, but we cannot see them. The core is a secret Saturn keeps. And yet, despite all this mass, despite being a world large enough to swallow Earth 100 times over, Saturn's most famous feature is almost absurdly delicate. The rings, which span 282,000 kilometers, are only about 1 kilometer thick, and in many places, they are far thinner than that. The rings have a vertical height of around 30 feet in some places, about as tall as a 3-story building. Imagine spreading something the thickness of a building across a distance greater than half the distance from Earth to the Moon. The rings are impossibly flat, impossibly thin, a structure that should not exist and yet does, spinning silently in the darkness. The rings are made of ice, water ice mostly, with some rocky material mixed in. The particles range in size from tiny grains to boulders tens of meters in diameter. Each particle is its own little moon, orbiting Saturn according to the same laws of motion that govern everything from planets to galaxies. Closer particles orbit faster. Farther particles orbit slower. This difference in orbital speed creates shearing forces that grind the particles together, breaking them into smaller pieces, but also clearing out gaps and sculpting the rings into the intricate patterns we observe. There are 7 main rings, designated A through G, each discovered and named as telescopes improved. The A and B rings are the brightest and most massive. They are separated by the Cassini division, a 4,800-kilometer gap named after Giovanni Cassini, who spotted it in the 1600s. The Cassini division is not truly empty. It contains sparse ring material, but it is much less dense than the rings on either side, creating the appearance of a gap. The division exists because of orbital resonances with Saturn's moons. Particles in the division orbit Saturn at a rate that is a simple fraction of the orbit of one of the moons, usually Mimas. This resonance creates gravitational tugs that gradually clear out the particles, sweeping them into neighboring regions and leaving the gap behind. The rings are complex beyond imagination. Within the main rings are thousands of ringlets, narrow bands separated by tiny gaps. There are spiral density waves caused by gravitational interactions with moons that propagate through the ring material like ripples on a pond. There are propeller structures, gaps carved by moonlets embedded within the rings, small objects that have cleared a path around themselves but are not large enough to be called moons. There are shepherd moons, small satellites that orbit just inside or outside a ring and use their gravity to keep the ring's particles confined, preventing them from spreading out. The F ring, one of the outer rings, is particularly chaotic, twisted into braids and knots by the gravitational influence of its shepherd moons. Cassini observed the F ring changing over time, evolving on timescales of hours and days, a dynamic structure unlike anything else in the solar system. The rings are also surprisingly young. Researchers have suggested these structures could be gone in another 15 million to 400 million years, and their youth implies they were formed relatively recently. Recent research suggests that Saturn's rings may have formed about 400 million years ago, roughly the time when the first fish were crawling onto land on Earth. Before that, Saturn may have been ringless. Something happened, some event, that created the rings we see today. Perhaps a moon wandered too close to Saturn and was torn apart by tidal forces, ripped into pieces that spread out into a disk. Perhaps a comet or asteroid struck one of Saturn's moons, shattering it and scattering its fragments into orbit. We do not know. The rings themselves hold no memory of their origin. They have been ground and reground by countless collisions, mixed and sorted by gravity, until any evidence of their birth has been erased. What we do know is that the rings are beautiful. They are beautiful in a way that transcends scientific understanding, in a way that touches something deep and primal in us. They are a reminder that the universe is capable of creating structures of astonishing elegance, that chaos and gravity and time can conspire to produce something that looks almost intentional, almost designed. The rings have no purpose. They serve no function. They simply are, a transient sculpture carved by physics, destined to exist for a brief moment in cosmic history and then fade away. And yet, as you lie there in the dark, consider this. Those rings have been there for hundreds of millions of years. They were there when dinosaurs walked the earth. They were there when our ancestors first stood upright and looked at the stars. They were there when Galileo pointed his telescope skyward and saw something he could not explain. Every human who has ever lived has lived under a sky that contained Saturn's rings. We are not separate from this story. We are part of it, brief witnesses to something ancient and beautiful and doomed. But Saturn's mysteries extend far beyond its rings. The planet itself is a world of wonders, each more strange than the last. At Saturn's North Pole, there is a hexagonal jet stream, a six-sided pattern that rotates with the planet. The sides of the hexagon are about 14,500 kilometers long, longer than the diameter of Earth. The hexagon is a persistent weather pattern, a storm that has existed for decades, possibly centuries. It was first observed by Voyager in 1981, and it is still there today, unchanged in its basic shape despite the chaotic nature of Saturn's atmosphere. How can a storm maintain such a precise geometric form? Why a hexagon rather than a circle or an oval or some irregular blob? These questions puzzled scientists for years. The hexagon rotates with a period of 10 hours, 39 minutes, and 24 seconds, the same period as Saturn's radio emissions from its interior, suggesting that it is somehow locked to the planet's deep rotation. But Saturn has no solid surface to provide a fixed reference point. The rotation rate we measure is the rotation rate of Saturn's magnetic field, generated deep in the metallic hydrogen layer far below the clouds. Somehow, that deep rotation communicates itself to the atmosphere thousands of kilometers above, organizing the chaos into a hexagon. The hexagon is a jet stream of winds moving at about 320 kilometers per hour, with a massive rotating storm at the center. The storm at the center has an eye about 50 times larger than the average hurricane eye on Earth. The eye is enormous, a swirling vortex large enough to swallow our entire planet. Around it, the hexagonal jet stream flows like a river, channeling smaller storms and vortices along its path. Some of these vortices spin clockwise, while the hexagon and hurricane spin counterclockwise, creating a complex choreography of motion within the larger structure. Scientists have replicated hexagonal patterns in laboratory experiments. By rotating a tank of water at different speeds at the center and edges, they can produce polygons, shapes with straight sides that seem impossibly geometric for a fluid system. The key is the interaction between the rotating fluid and slower moving fluid around it, which creates instabilities that organize into wave patterns. Depending on the speeds and properties of the fluid, the waves can lock into different shapes: triangles, squares, hexagons, octagons. Saturn produces a hexagonal jet stream because of the specific speeds and properties of its atmosphere at that latitude. Change those conditions slightly, and the shape would change. But the conditions at Saturn's North Pole have remained stable for decades, and so the hexagon endures. Strangely, Saturn's South Pole does not have a hexagon. It has a vortex, a storm, but not the geometric precision of the North. Why this asymmetry exists is unclear. Perhaps it has to do with subtle differences in temperature or wind speed between the two poles. Perhaps it is simply chance, an accident of initial conditions that has persisted because there is nothing to disrupt it. The lack of a southern hexagon reminds us that even in a universe governed by physical laws, outcomes can be unpredictable, shaped by factors too small or too complex for us to fully understand. During Cassini's mission, the hexagon changed color from mostly blue to more of a golden color. This color change was driven by the arrival of northern summer. As sunlight increased, solar radiation broke apart methane molecules in the atmosphere, which rearranged into hydrocarbon particles similar to smog on Earth. These particles scattered light differently, shifting the hexagon's appearance from blue to gold. The color change is a visible reminder that Saturn's atmosphere is active, dynamic, responding to the slow pulse of its seasons. The hexagon is just one of many storms on Saturn. In December 2010, a massive storm erupted in Saturn's northern hemisphere, eventually encircling the entire planet. This storm, sometimes called the Great White Spot, was a once-in-a-Saturnian generation event, a 30-year storm that arrived 10 years early. It raged for months, producing the largest temperature increases ever recorded for any planet, according to measurements by Cassini. Even after visible signs of the storm faded, infrared measurements revealed powerful effects still at work in Saturn's stratosphere, with molecules never before seen in Saturn's upper atmosphere. The storm eventually collided with its own tail as it wrapped around the planet, a serpent devouring itself, and dissipated. But for those months, Saturn was a world at war with itself, its atmosphere convulsing with energy released from deep below. These storms are not just meteorological curiosities. They are windows into Saturn's interior, ways of probing the hidden depths of a planet we can never directly observe. The energy that drives Saturn's weather comes from within, from the slow cooling of the planet, from the gradual settling of helium rain deep in the interior. Helium, denser than hydrogen, sinks toward the core over millions of years, releasing gravitational energy as it falls. This process heats the planet from within, providing the fuel for its storms. Understanding Saturn's weather helps us understand its internal structure, its composition, its history. Saturn does not exist in isolation. It is surrounded by a family of moons, a complex system that rivals the Sun's system of planets in its diversity and richness. Saturn has at least 145 moons, ranging from tiny irregular rocks a few kilometers across to Titan, a world larger than the planet Mercury. Each moon is unique, each with its own story, its own geology, its own mysteries. Some are icy and cratered, ancient surfaces that have changed little since the solar system's formation. Others are active, geologically alive, with volcanoes and geysers and shifting landscapes. Titan, the largest moon, is the second largest moon in the solar system. It has a substantial atmosphere rich in nitrogen and methane, denser than Earth's atmosphere, thick enough to hide the surface from view. When the Huygens probe, carried to Saturn by Cassini, and released a parachute down to Titan's surface in 2005. Descended through the smog, it revealed a world of startling familiarity. Titan has rain, rivers, lakes, and seas, but they are not made of water. They are made of liquid methane and ethane, hydrocarbons that on Earth are gases, but on Titan, where the temperature is minus 180 degrees Celsius, exist as liquids. Titan has weather, seasons, erosion, a hydrological cycle that mirrors Earth's in every way except the substance involved. It rains methane on Titan. Rivers of methane carve channels through hills of water ice, which on Titan is as hard as rock. Methane lakes dot the polar regions, dark pools beneath a hazy orange sky. Titan is, in some ways, Earth's cold twin, a world where the same processes operate, but with different materials. It may be a window into Earth's distant past. Titan's atmosphere might be similar to what Earth's was like long ago, before oxygen transformed our world. Studying Titan helps us understand how atmospheres evolve, how organic chemistry works in extraterrestrial environments, how life might arise in places we would never expect. But Titan is not the strangest of Saturn's moons. That distinction might belong to Enceladus, a small icy moon barely 500 kilometers in diameter. Cassini discovered icy plumes spraying from fractures on Enceladus's surface, leading to the understanding that the moon possesses a global ocean of liquid water beneath its icy shell. This discovery transformed our view of where life might exist in the solar system. Enceladus is tiny, far from the sun, frozen on the surface, and yet beneath that ice there is an ocean, kept liquid by tidal heating as Saturn's gravity flexes the moon's interior. The geysers eject water vapor and organic materials from beneath the surface, suggesting the presence of subsurface oceans that could potentially harbor life. Water, organic molecules, heat, these are the ingredients for life as we know it, and they all exist on Enceladus. The moon is, by the standards we use to assess habitability, one of the most promising places in the solar system to search for extraterrestrial life. Not advanced life, not intelligence, but microbial life, simple organisms that might exist in the dark ocean beneath the ice, clustered around hydrothermal vents, drawing energy from chemical reactions in the rocks. Cassini flew through Enceladus's plumes, sampling their composition, detecting not just water but also salts, silica, and complex organic compounds. The evidence is tantalizing, though far from definitive. To know for sure, we would need to go back, to land on Enceladus, or drill through the ice, or send a submarine into that hidden ocean. Such missions are decades away, but they are being planned, dreamed about, designed. Someday, we may have an answer. Other moons discovered during ring plane crossings include Hyperion, Epimetheus, Janus, Calypso, Helene, and Telesto. These small moons, irregular chunks of ice and rock, were invisible when the rings were edge-on and bright, hidden in the glare. But when the rings vanished during previous ring plane crossings, astronomers could search the space around Saturn more easily, finding moons that had eluded detection before. Giovanni Cassini discovered 4 of Saturn's moons during ring plane crossings in the late 1600s. The disappearance of the rings, far from being merely an optical curiosity, has been a valuable tool for discovery, a reminder that sometimes removing the brightest object makes it easier to see the faint. Each of Saturn's major moons has its own personality. Mimas, with its giant impact crater, resembles a certain famous fictional space station, earning it the nickname the Death Star moon. Iapetus has one dark hemisphere and one bright hemisphere, a stark contrast caused by the accumulation of dark material from another moon. Hyperion is sponge-like, porous, tumbling chaotically through space rather than rotating smoothly. Phoebe orbits backwards, a captured object that did not form with Saturn, but was snatched from the outer solar system. Together, these moons form a miniature solar system, a laboratory for studying orbital dynamics, tidal interactions, and the processes that shape celestial bodies. The Cassini mission, which studied Saturn from 2004 to 2017, transformed our understanding of the planet and its system. Cassini completed its initial 4-year mission in June 2008 and earned 2 mission extensions that enabled the team to delve even deeper into Saturn's mysteries. The spacecraft orbited Saturn 294 times, flew by Titan more than 100 times, discovered new moons, observed changing weather patterns, measured the ring's mass and composition, sampled Enceladus's plumes, and captured images of breathtaking beauty. In late 2016, Cassini began a daring set of orbits called the Grand Finale. The spacecraft had run low on fuel, and mission planners faced a choice. They could let Cassini drift aimlessly through the Saturn system until contact was lost, or they could end the mission intentionally with purpose and drama. They chose the latter. Cassini dove between Saturn's atmosphere and its innermost ring 22 times, threading a gap barely wide enough to fit the spacecraft, a region never before explored. The maneuver was risky. If Cassini hit even a small particle of ice at that speed, the mission would end instantly. But the spacecraft survived, collecting unprecedented data with each pass. It measured Saturn's gravitational field with extraordinary precision, revealing details about the planet's interior structure. It sampled the upper atmosphere directly, tasting the gases that make up Saturn's outermost layers. It observed the rings from closer than ever before, resolving features invisible from greater distances. And then, on September 15, 2017, Cassini plunged into Saturn's atmosphere and burned up. The decision to destroy the spacecraft was not made lightly. Cassini was still functioning, still sending data, still capable of doing science. But its fuel was nearly exhausted, and mission planners could not risk the spacecraft crashing into Enceladus or Titan in the future, potentially contaminating those moons with Earth microbes. Better to end the mission deliberately, to sacrifice Cassini in Saturn's atmosphere, ensuring that it would never threaten the pristine environments of moons that might harbor life. As Cassini descended, it transmitted data until the very end, sending back measurements of the atmosphere's composition, even as the spacecraft disintegrated. It was a fitting end for a mission that had revealed so much. Cassini's legacy is immense. The data it collected will be analyzed for decades. New discoveries continue to emerge from the archives, patterns and phenomena that were captured but not immediately recognized. The mission answered countless questions, but also raised new ones, as all good science does. Why does Saturn have a hexagon and Jupiter does not? How old are the rings really? What is happening in Enceladus's ocean? What drives Titan's weather? How do Saturn's moons interact with the rings? Each answer leads to more questions, an endless unfolding of mystery. Future missions to Saturn are being contemplated. Proposals exist for orbiters, landers, submarines, drones. Imagine a quadcopter flying through Titan's thick atmosphere, landing on the shores of a methane sea, scooping up samples to analyze. Imagine a probe diving beneath Enceladus's ice, exploring that hidden ocean, searching for signs of life. These missions are technically feasible. The challenge is not capability, but funding, political will, patience. Space exploration moves slowly, measured in decades rather than years. But it moves. We will return to Saturn. We will delve deeper into its mysteries. The story is not finished. As you rest, as your thoughts begin to blur and soften, let us return to the rings, to the temporary vanishing and the permanent loss. During the last ring plane crossing in 1995, scientists spotted Saturn's E-ring for the first time. This diffuse ring is the outermost of the planet's 7 and can only be seen at ring plane crossings. The E-ring is faint, broad, and tenuous, fed by particles from Enceladus's geysers. Most of the time, it is lost in the glare of the brighter rings, invisible against their brilliance. But when the main rings disappear, the E-ring becomes detectable, a ghostly arc encircling Saturn at a great distance. What else might we discover when the rings vanish this time? Perhaps new moons, small objects that have escaped detection until now. Perhaps variations in the ring structure, gaps or waves that are usually hidden. Perhaps nothing new at all. The universe does not owe us discoveries, but the search itself is valuable. The act of looking, of paying attention, of noticing what changes when conditions shift. Science is, at its core, careful observation. The ring plane crossing is an opportunity to observe Saturn in a state we rarely see, and that opportunity should not be wasted. But observation is difficult this time. Saturn's rings will gradually become visible again over the following months through large telescopes before fading from view a second time in November 2025. By 2027, the rings will be fully visible again, tilted toward Earth, displaying their full glory. The cycle will continue as it has for millions of years, as it will for millions more, until the rings are truly gone. The permanent disappearance of Saturn's rings is difficult to imagine. We have known Saturn as the ringed planet for as long as we have had telescopes powerful enough to reveal the rings. They are inseparable from our conception of the planet, as fundamental to Saturn's identity as its moons or its storms. A ringless Saturn seems incomplete, diminished, ordinary, and yet that is Saturn's future. Knowing how Saturn's rings are withering away, scientists have suggested that other planets' rings, which are currently darker and less pronounced, may have one day been as splendid as Saturn's before the forces of ring rain wore them down. Jupiter, Uranus, and Neptune all have ring systems, but they are faint, narrow, easy to miss. Perhaps they were once magnificent, glowing with reflected sunlight, and have faded over time. Perhaps Saturn's rings are the last great ring system in the solar system, the final ember of something that once burned brighter. Or perhaps ring systems come and go, created and destroyed by cosmic accidents, by impacts and tidal disruptions, and the slow grinding of gravity. Perhaps Saturn will be ringless for a time, and then acquire new rings from some future collision, a moon shattered, or a comet captured. The universe is old, and Saturn is patient. What we see is only a snapshot, a single frame in a film that has been playing for billions of years and will continue for billions more. James O'Donoghue, an astronomer who studied Saturn's ring rain, said in 2018, "We are lucky to be around to see Saturn's ring system, which appears to be in the middle of its lifetime." This is the thought to hold on to as you drift. We are lucky. Of all the moments in cosmic history when consciousness could arise, when beings capable of understanding could emerge, we find ourselves here now, witnesses to Saturn's crown. The rings have been there for millions of years before us. They will persist for millions of years after we are gone. But right now, in this brief sliver of time, we share the universe with them. We can look up, point a telescope skyward, and see them. We can study them, photograph them, marvel at them. We are participants in their story, even if only for an instant. There is something profoundly moving about impermanence. If Saturn's rings were eternal, unchanging, they might become ordinary, background features we take for granted. But knowing they are temporary, that they are vanishing even as we watch, adds urgency and poignancy to their beauty. It reminds us that nothing lasts forever, not stars, not planets, not rings, not us. Everything is transient, a pattern that emerges from chaos and will eventually return to chaos. The rings are stardust, shaped by gravity into elegance, destined to fall and be absorbed, their atoms recycled into Saturn's atmosphere, perhaps to be blown away by solar wind, perhaps to be incorporated into future moons or other structures we cannot yet imagine. This is not sad, not truly. It is simply the way of things. The universe is not static. It changes, evolves, transforms. Stars are born and die. Galaxies collide and merge. Planets form and eventually will be consumed by their expanding suns. Impermanence is the price of existence, the condition of being part of a dynamic, evolving cosmos. And there is beauty in that, a fierce, bittersweet beauty that comes from knowing that every moment is unique, that the now we inhabit will never come again. Saturn spins on, indifferent to our thoughts, unaware of its own magnificence. It does not know it is beautiful. It does not mourn the loss of its rings. It simply is, following the laws of physics, responding to forces, existing. And yet, through us, through consciousness, the universe becomes aware of itself. We are the part of the cosmos that can look back and appreciate, that can feel awe, that can recognize beauty. In a very real sense, we are the universe admiring itself. When you gaze at an image of Saturn, when you imagine those rings spinning silently in the void, you are not separate from what you observe. You are made of the same atoms, forged in the same stellar furnaces, governed by the same physical laws. You are stardust contemplating stardust, a pattern of matter and energy complex enough to wonder about other patterns. This perspective can be overwhelming or it can be comforting, depending on how you hold it. On one hand, it emphasizes our smallness, our insignificance in the vastness of space and time. On the other hand, it connects us to everything, erasing the boundary between self and universe. You are not just in the universe, you are of it, an integral part of its unfolding story. The atoms in your body were once inside a star, scattered by a supernova, drifting through space, eventually coalescing into the solar system, into Earth, into life. You are ancient and you are new, a temporary arrangement of ancient materials destined to dissolve and reform into something else. The carbon in your muscles, the calcium in your bones, the iron in your blood, all of it came from stars. You are, quite literally, made of starlight. Saturn's vanishing rings remind us to pay attention, to appreciate what is here while it is still here. This applies not just to astronomical phenomena, but to everything. The people we love, the experiences we cherish, the world around us, all of it is impermanent. All of it will eventually change or end. This is not a cause for despair, but a reason for gratitude. We are here now, able to witness, able to feel, able to understand. That is a gift, however brief. The rings will disappear temporarily in March, a trick of geometry, an alignment of orbits. They will return, tilted back into view, and we will have many more years to admire them. But eventually, on timescales we can barely comprehend, they will fade for good, raining down onto Saturn particle by particle, until nothing remains but memories and photographs. Future generations will inherit a different Saturn, a world without rings, and they will look at our images with a mixture of wonder and envy, wishing they could have seen what we saw. But perhaps they will have their own wonders, their own transient beauties to marvel at. The universe is creative, endlessly inventive. It produces stars and planets, galaxies and black holes, life and consciousness. It experiments, iterates, evolves. What is lost is mourned, but what is created is celebrated. The end of one thing makes space for the beginning of another. Saturn's rings will fall, but the atoms that compose them will not disappear. They will become part of Saturn, part of its atmosphere, part of its story. And that story will continue, unfolding in ways we cannot predict, driven by forces we are only beginning to understand. As you lie there, feeling the weight of your body against the surface beneath you, feeling the slow rhythm of your breath, imagine Saturn. Imagine it spinning in the dark, crowned in ice, surrounded by its family of moons. Imagine the rings, so thin they could vanish if you turned your head, so vast they could swallow our entire planet. Imagine the hexagonal storm at the North Pole, the winds howling at speeds we can barely comprehend. Imagine the geysers on Enceladus, jetting water into space, feeding the E-ring, perhaps harboring life in the hidden ocean below. Imagine Titan with its methane rain and its lakes and its thick orange haze. Imagine Cassini diving through the gap between planet and ring, measuring, photographing, transmitting data back to Earth, fulfilling its purpose until the very last second before burning up in the atmosphere. Imagine all of this and know that it is real. It is not fantasy, not fiction, not imagination. It is happening right now, as you rest, as you breathe, as you listen to these words. Saturn exists. It orbits the sun. It spins on its axis. It holds its moons in gravitational embrace. It loses its rings grain by grain. And somewhere, on a small blue planet orbiting an ordinary star in an unremarkable part of a spiral galaxy, beings made of stardust have built machines and sent them across the void to see Saturn up close, to measure it, to understand it, to marvel at it. That is what we are. That is what we do. We explore, we learn, we share what we find. We tell stories about the universe because the universe is the grandest story there is. The story of Saturn is also the story of discovery, of how human curiosity and ingenuity have gradually revealed the secrets of distant worlds. When Galileo first observed Saturn in 1610, he described what he saw as ears or handles on either side of the planet. His telescope was primitive, barely more powerful than a pair of binoculars, and he could not resolve the rings clearly. They appeared as two separate objects flanking the planet, mysterious protrusions that made no sense. When those ears disappeared in 1612 during a ring plane crossing, Galileo was baffled. He wondered if Saturn had swallowed its children, a reference to the Roman myth of the god Saturn devouring his offspring. He never solved the mystery. He died in 1642, 11 years before the Dutch astronomer Christian Huygens correctly identified the ears as a ring system encircling the planet. Huygens published his discovery in 1655, using an anagram to establish priority while he confirmed his observations. Later, he revealed the solution. It is surrounded by a thin, flat ring, nowhere touching, inclined to the ecliptic. This was revolutionary. No one had imagined that a planet could have rings. The idea seemed absurd, impossible. How could a ring remain stable, not falling onto the planet or flying apart? But Huygens's observations were correct, and over the following decades, other astronomers confirmed his findings. Giovanni Cassini built upon Huygens's work, discovering in 1675 that the ring was not a single structure, but was divided into multiple rings with gaps between them. The gap he discovered, now called the Cassini division, proved that the rings were complex, not simple. For centuries, the nature of the rings remained unclear. Were they solid, liquid, made of countless small particles? Theoretical work by James Clerk Maxwell and others in the 1800s demonstrated that the rings had to be composed of many small objects, each orbiting independently. A solid ring would be unstable, torn apart by tidal forces. A liquid ring would behave differently than observations showed. Only a swarm of particles, a disk of countless moons, could explain the ring's behavior. This was confirmed in the 1900s by spectroscopic observations, which showed that different parts of the rings moved at different speeds, exactly as expected if they were composed of individual particles obeying Kepler's laws of orbital motion. The Voyager missions in the 1980s provided the first close-up views of Saturn's rings, revealing their intricate structure in stunning detail. The simple broad bands visible from Earth resolved into thousands of ringlets, gaps, waves, and features that had never been imagined. The rings were not uniform. They were dynamic, changing, sculpted by forces both large and small. Voyager also discovered new moons, found gaps and braids in the rings, and measured the thickness of the rings directly for the first time. The data from Voyager filled textbooks, reshaped our understanding, and raised questions that would take decades to answer. And then came Cassini, which spent 13 years in orbit around Saturn, studying the system in exhaustive detail. Cassini's cameras captured images of breathtaking clarity, showing the rings in visible light, infrared, ultraviolet, revealing composition, temperature, structure. Cassini's instruments measured the gravitational field, the magnetic field, the plasma environment, the dust, the gas. Cassini deployed the Huygens probe to Titan, landing on an alien world and sending back images of a surface that looked eerily Earth-like, with rivers and lakes and erosion, all made of materials that would be gases on Earth. Cassini discovered geysers on Enceladus, revealing the hidden ocean, transforming a tiny icy moon into one of the most interesting places in the solar system. Cassini observed storms, including the Great Storm of 2010 that encircled the planet. Cassini measured ring rain, confirming that the rings are vanishing, that their beauty is temporary. Every mission to Saturn has built upon the discoveries of the previous ones. Galileo saw something strange. Huygens identified it as rings. Cassini found gaps. Maxwell proved they were particulate. Voyager revealed their complexity. Cassini uncovered their impermanence. And future missions, not yet launched, will delve even deeper, answering questions we have not yet thought to ask, discovering phenomena we cannot yet imagine. This is how science progresses, incrementally, each generation standing on the shoulders of the previous, seeing a little farther, understanding a little more. Saturn's influence extends far beyond its immediate vicinity. The planet's gravity shapes the orbits of nearby objects, clearing out regions of the asteroid belt, shepherding moons, sculpting the rings. Saturn's magnetic field, though weaker than Jupiter's, still extends for millions of kilometers, creating a magnetosphere that traps charged particles and generates auroras at the poles. These auroras, like Earth's northern and southern lights, are caused by particles from the solar wind spiraling down magnetic field lines and colliding with atmospheric gases, exciting them and causing them to glow. Saturn's auroras are less intense than Jupiter's, but more extensive than Earth's, shimmering curtains of light that dance across the polar skies, visible in ultraviolet wavelengths, invisible to human eyes but captured by spacecraft instruments. Saturn also plays a role in the structure of the solar system. It is one of the gas giants, along with Jupiter, Uranus, and Neptune, that dominate the outer solar system. These planets contain the majority of the mass in the solar system outside the Sun. Their gravity has shaped the distribution of smaller objects, flinging some into the inner solar system, ejecting others into the distant reaches, creating the architecture we observe today. Theories of solar system formation suggest that the gas giants may have migrated, moving inward or outward from their initial positions, driven by gravitational interactions with the disk of gas and dust from which they formed. Saturn may once have orbited closer to the Sun or farther away before settling into its current position. These migrations would have had profound effects on the rest of the solar system, possibly triggering events like the Late Heavy Bombardment, a period about 4 billion years ago when the inner planets were struck by a surge of asteroids and comets. Saturn's existence may have influenced the development of life on Earth. By clearing out much of the debris in the outer solar system, by acting as a gravitational vacuum cleaner, Saturn and Jupiter reduce the number of comets and asteroids that fall into the inner solar system, reducing the frequency of catastrophic impacts on Earth. This protective role is not absolute. Impacts still occur, as the dinosaurs learned 66 million years ago. But it may have made Earth a safer place for life to evolve. Without the gas giants, Earth might have been struck more frequently, potentially sterilizing the surface repeatedly, preventing complex life from gaining a foothold. This is speculative, but it highlights how interconnected the solar system is, how the presence of one planet can influence the fate of another. Saturn's seasons are long, each lasting over 7 Earth years. The planet's axis is tilted by 26.7 degrees, similar to Earth's tilt of 23.5 degrees. And this tilt causes seasonal variations in sunlight and temperature. During northern summer, the North Pole is tilted toward the Sun, receiving more sunlight, warming slightly, becoming more active. During northern winter, the North Pole is in shadow, cooling and quieting. The hexagon at the North Pole changes color with the seasons as chemical processes respond to the varying sunlight. The southern hemisphere undergoes opposite changes. Winter when the north has summer, summer when the north has winter. These seasonal changes are subtle compared to Earth's. Saturn is so far from the Sun that the variation in sunlight between summer and winter is relatively small. The planet's internal heat, which radiates more energy than it receives from the Sun, moderates the seasonal effects, preventing dramatic swings in temperature. Still, the seasons are there, measurable, real, a slow cycle that repeats every Saturnian year, every 30 Earth years. Titan's seasons are more pronounced. The thick atmosphere responds strongly to changes in sunlight, creating weather patterns that shift from north to south and back again. During Titan's northern winter, methane clouds accumulate over the North Pole, producing rain that fills the northern lakes. During northern summer, the clouds shift to the south. The Cassini mission observed this seasonal transition, watching as Titan's atmosphere reorganized itself over the course of years. These observations provided insights into atmospheric dynamics, into how liquids cycle through an atmosphere, into the processes that shape weather on any world with sufficient mass and volatiles. Enceladus, by contrast, has no atmosphere to speak of, and its seasons are defined not by sunlight, but by tidal forces. As Enceladus orbits Saturn, the planet's gravity squeezes and flexes the Moon's interior, generating heat through friction. This heat melts ice, creating the subsurface ocean, driving the geysers that erupt from the South Pole. The intensity of the geysers may vary with Enceladus's position in its orbit, stronger when the Moon is closer to Saturn, weaker when it is farther away. This creates a kind of seasonal cycle, not based on sunlight, but on gravity, a tidal season that repeats every 33 hours, the length of Enceladus's orbital period. Each moon has its own rhythms, its own cycles, its own relationship with time. Some spin synchronously, always showing the same face to Saturn, locked by tidal forces the way our moon is locked to Earth. Others tumble chaotically, their rotation periods irregular, unpredictable. Some have orbital resonances with other moons, their periods related by simple ratios, 2:1, 3:2, creating gravitational dances that have persisted for millions of years. The Saturn system is a clockwork, intricate and beautiful, each piece moving in relation to the others, the whole maintained by gravity, by momentum, by the conservation of energy and angular momentum. As you settle deeper into rest, let us consider scale once more, because scale is essential to appreciating Saturn. Imagine you could travel to Saturn, not instantly, but at the speed of current spacecraft. The journey would take about 7 years, depending on the alignment of the planets and the trajectory chosen. 7 years of traveling through space, watching Earth shrink to a pale blue dot, watching the Sun grow slightly smaller, crossing the asteroid belt, passing Jupiter, finally arriving at Saturn. 7 years. Cassini launched in 1997 and arrived in 2004. Voyager 1 launched in 1977 and reached Saturn in 1980. These are not quick trips. They require patience, planning, precise calculations, Years of work by thousands of people, all to send a single spacecraft across the void. And yet, despite the distance, despite the time, we have been there. Our machines have flown by Saturn, orbited it, studied it, descended to its moons, sampled its atmosphere. We have, in a very real sense, touched Saturn. Not with human hands, not yet, but with our instruments, our cameras, our sensors. We have extended our presence across nearly 1 billion miles of space, defying the vastness, asserting our curiosity and our ingenuity. When will humans visit Saturn? Not soon, likely. The challenges are immense. The distance is too great, the radiation too intense, the environment too hostile. Even reaching Mars, a fraction of the distance, is a monumental undertaking that may take decades. Saturn is farther still, and there is no surface to land on, only gas and pressure and heat that would crush any spacecraft long before it reached anything resembling a core. But Saturn's moons are another matter. Titan has a surface, an atmosphere, resources that could potentially be used. Enceladus has water, energy, possibly life. These are destinations worth considering, worth planning for, worth dreaming about. Perhaps in a century or two, there will be outposts on Titan, research stations studying the methane lakes, the organic chemistry, the possibility of life. Perhaps there will be submarines in Enceladus's ocean, exploring the depths, searching for organisms, mapping the seafloor. Perhaps humans will stand on the icy surface of one of Saturn's moons and look up at the planet, seeing the rings from a perspective we have never had, a view that would make even the most stunning photographs seem inadequate. These are distant possibilities, speculative, uncertain, but they are not impossible. Nothing in physics prevents them. It is only a matter of time, resources, will. For now, we must be content with what we have: images, data, knowledge, understanding. We can admire Saturn from afar, appreciating its beauty without possessing it, without altering it, without diminishing it. There is something noble in that, a kind of respectful distance. We observe, we study, we learn, but we do not conquer. Saturn remains Saturn, vast and indifferent, spinning on in the darkness, unconcerned with our attention. The mathematics of orbital mechanics, the physics of gravity, the chemistry of ices and gases, all of these come together in Saturn, creating a system of astonishing complexity that nevertheless obeys simple, elegant laws. Newton's law of gravitation, a single equation, explains the motion of every moon, every ring particle, every atom in Saturn's atmosphere. F equals g times m1 times m2 divided by r squared. Force equals the gravitational constant times the product of two masses divided by the square of the distance between them. This simple relationship governs everything, from the fall of an apple to the orbit of a galaxy. It is universal, timeless, exact, and yet, despite its simplicity, it produces outcomes of staggering complexity. The three-body problem, the interaction of just three objects under gravity, has no general solution. It must be calculated numerically, step by step, each position depending on the previous. Add more bodies, and the complexity explodes. Saturn has over 100 moons, countless ring particles, all interacting gravitationally. The system is chaotic in the technical sense, sensitive to initial conditions, unpredictable over long timescales, and yet it persists, stable on human timescales. A structure that has existed for billions of years, and will continue for billions more. This interplay between simplicity and complexity, between order and chaos, is one of the deep themes of science. The laws are simple. The outcomes are not. A snowflake forms according to straightforward physical principles, the way water molecules bond, the way ice crystals grow. But every snowflake is unique, shaped by the particular conditions it experiences as it falls. Saturn's rings follow the same basic laws, but their structure is unique, shaped by the specific history of the system, by the moons that happen to exist, by the impacts and interactions that have occurred over eons. There is beauty in this, a kind of aesthetic pleasure that comes from understanding, from seeing how the pieces fit together, how the simple gives rise to the complex. Science is not dry or cold or mechanical. It is a way of appreciating the world, of finding patterns, of revealing the hidden order that underlies apparent chaos. When you understand why Saturn has a hexagon, when you grasp the physics of ring rain, when you see how tidal heating creates oceans on tiny moons, you are not diminishing the wonder. You are deepening it, enriching it, making it more meaningful. Let us return once more to the rings, to their temporary and permanent disappearances, because this is the heart of the mystery that brought you here tonight. The rings will reappear as they always have, and we will see them again, tilted back into view, reflecting sunlight, beautiful and fragile. But this temporary vanishing is a reminder of the permanent vanishing, the slow dissolution that is happening all the time, invisible to our eyes, measured not in hours or days, but in millions of years. Every 30 minutes, an Olympic swimming pool's worth of water rains down from the rings onto Saturn. This is ring rain, a consequence of Saturn's magnetic field, of ultraviolet light from the sun, of the electrical charges that accumulate on ice particles and make them vulnerable to electromagnetic forces. The particles spiral down invisible field lines, crossing the gap between ring and planet, disappearing into the clouds. They do not burn up as meteors do in Earth's atmosphere. They simply dissolve, merging with the hydrogen and helium, becoming a part of Saturn. The rings are feeding the planet slowly, quietly, giving themselves up atom by atom. This process has been going on for as long as the rings have existed, and it will continue until the rings are gone. Scientists estimate the rings will be gone in less than 100 million years, possibly as few as 15 million. This seems like a long time, and it is by human standards. But it is brief by cosmic standards, a fleeting moment in the life of Saturn. The planet is 4.5 billion years old. The rings, if they last another 100 million years, will have existed for perhaps 2% of Saturn's total lifetime. They are an adornment of the planet's middle age, a temporary decoration that will not last into old age. What will Saturn look like without rings? Smaller, perhaps. Less impressive. A gas giant like any other, with interesting moons and complex weather, but no defining feature, no visual signature that sets it apart. The rings are Saturn's crown, and without them, the planet will be diminished, at least in our eyes. But Saturn will not care. It will continue to spin, to radiate heat, to hold its moons, to exist. The absence of rings will not affect its function, its place in the solar system, its destiny. Only our perception will change. And perhaps that is the lesson. Beauty is not intrinsic. It is a relationship between the observer and the observed, a pattern that resonates with our minds, our aesthetics, our sense of harmony. The rings are beautiful because we perceive them as beautiful. Saturn, indifferent, does not notice. This does not diminish the beauty. If anything, it emphasizes it. Beauty is rare, precious, fragile. It depends on the existence of minds capable of recognizing it, of appreciating it, of caring about it. Without consciousness, without observers, the universe would still exist, but it would not be beautiful. Beauty is what happens when the universe becomes aware of itself, when matter organizes into patterns complex enough to reflect and appreciate other patterns. In the silence of your room, in the darkness behind your eyelids, imagine Saturn one last time. See it spinning in the void, 9.5 times farther from the sun than Earth. A pale yellow sphere surrounded by shimmering rings. See the hexagon at the North Pole, the storms swirling through the atmosphere, the moons orbiting in their precise, gravitationally determined paths. See Titan, shrouded in haze, with its methane lakes and rivers. See Enceladus, tiny and bright, with geysers erupting from fractures in its southern hemisphere. See the rings, 282,000 kilometers across, but only a kilometer thick. A disk of ice particles, each on its own path, each a tiny moon, all of them together creating something impossibly beautiful. See all of this and know that it is happening right now in the real universe, not in fantasy, but in fact. Saturn exists. It orbits the sun. It is losing its rings slowly, inexorably, grain by grain. And you, lying here in the dark, are connected to it, made of the same materials, governed by the same laws, part of the same cosmic story. The atoms in your body came from stars. The elements that make up Saturn came from the same stellar furnaces. You are not separate from the universe. You are a piece of it, a part of the whole, briefly conscious, briefly aware, briefly capable of wonder. This is the gift of existence, the privilege of being alive and aware in a universe vast beyond comprehension, old beyond imagining, filled with wonders we are only beginning to discover. Saturn's rings are disappearing, both temporarily and permanently, and that disappearance is a reminder to pay attention, to appreciate, to be present. Nothing lasts forever. Everything changes. The universe is in constant flux, and we are part of that flux, patterns that emerge and dissolve, temporary arrangements of matter and energy, here for a moment and then gone. But while we are here, we can look up, we can wonder, we can learn, we can share what we discover with others, weaving a web of knowledge that spans generations, connecting past and future, ensuring that what we learn is not lost. This narration, these words, are part of that web, a thread connecting you to Saturn, to the scientists who study it, to the engineers who built the spacecraft, to the thinkers who first puzzled over the rings, all the way back to Galileo, peering through his primitive telescope, seeing something he could not explain. We stand on the shoulders of giants, and we add our own small contributions so that future generations can stand on our shoulders and see farther still. This is the human story, the story of curiosity and exploration, of asking questions and seeking answers, of pushing boundaries and expanding our understanding. Saturn is part of that story. The disappearing rings, both the temporary illusion and the permanent dissolution, are part of that story. And you, listening to these words, drifting towards sleep, are part of that story too. Let the quiet settle now. Let your thoughts slow, your breath deepen, your body relax completely. There is no need to hold on to anything, no need to remember every detail. The knowledge is there when you want it, preserved in books and articles, in images and data, in the collective understanding of humanity. For now, simply rest. Let the vastness of space hold you, gently, the way darkness holds light. Saturn continues its journey, indifferent to your attention, but beautiful nonetheless. The rings continue their slow reign, feeding the planet, dissolving into history. The moons continue their orbits, Titan with its methane lakes, Enceladus with its hidden ocean, all of them spinning through the void, part of a system that has endured for billions of years and will endure for billions more. You are safe here, in this moment, in this place. The universe is vast, but you are part of it, connected to everything, made of stardust, shaped by the same forces that shape planets and rings and moons. There is wonder here, and there is peace. The wonder of understanding, the peace of acceptance, the knowledge that you are exactly where you should be, part of something larger than yourself, something beautiful and ancient and ongoing. As the night wraps softly around you, as sleep edges closer, know that Saturn will still be there tomorrow, still spinning, still crowned in light, still slowly losing that crown. In some distant future you will never see, they will vanish for good, dissolved into the planet, their story finished, their beauty passed into memory. But that is not tonight. Tonight, they are still there, still shining, still calling out to anyone who cares to look, to wonder, to dream. Rest now. Let Saturn spin on in the darkness. Let the rings perform their slow dissolve, their elegant descent. Let Enceladus spray its geysers into space. Let Titan's methane rain fall softly on alien shores. Let the universe continue its vast unfolding, its endless creativity, its patient transformation of energy into matter, chaos into order, simplicity into complexity. You are part of this. You are a thought the universe is thinking, a way for the cosmos to know itself. And for now, for this moment, that is enough. Good night. We will meet again, under these same stars, in this same vast universe, to explore another wonder, another mystery, another piece of the cosmic puzzle. Until then, rest well, dream deeply, and know that somewhere out there, nearly 1 billion miles away, a strange planet with a disappearing crown spins on, indifferent and magnificent, temporary and eternal. A jewel in the darkness, slowly fading, but not yet gone.